Hello friends, welcome to Unreal Blueprints video tutorials series. From the past few video tutorials, we are trying to understand math functions in Unreal Blueprint. In this video, I would like to discuss math expression node in Unreal Blueprint. Math expression node allows us to directly type a math expression. Math expression node allows us to directly type a math expression, and based on the given math expression, it creates a graph of nodes within it. It itself creates a graph of nodes, guys. It rewrites the given math expression by following BODMAS rule, where B stands for brackets, O for orders, D for division, M for multiplication, A for addition, S for subtraction. First brackets are evaluated, then orders, then division and multiplication, then addition and subtraction, guys. And remember, identifiers are converted to data pins. Identifiers are converted to data pins. What are identifiers? A single character or sequence of characters is considered as an identifier, guys. An identifier followed by pair of parentheses is considered as a function. Identifier followed by pair of parentheses is considered as a function. Let's have a demo and understand everything step by step. How do we add a math expression node? Just right click in the event graph and search for add math expression node. So if you select math expression node, it allows you to directly type a math expression. Okay, and it rewrites the given math expression based on BODMAS rule. So if I say 2 plus 3 into 5, okay, what happens here? 2 plus 3 is 5, 5 into 5 is 25. That is wrong, guys. That is wrong answer. As per BODMAS rule, first multiplication should be evaluated, then addition. So 3 into 5 is 15, 15 plus 2 is 17. 17 is the correct answer, guys. 2 plus 3 multiplied by 5. I right click here and search for add math expression node. 2 plus 3 multiplied by 5. So what happens in this case? I just wrote 2 plus 3 multiplied by 5. Here star indicates multiplication operator, guys. Plus indicates addition operator. As it knows that multiplication operator should be evaluated first, it puts brackets before and after 3 into 5. So if I hit enter, you see that it has put brackets. You can see that I have not put brackets. Math expression node is placing the brackets. It knows what to do. Now if I right click here and say print string, connect the execution pins and connect the data pin, definitely we will get 17 because 5 into 3 is 15. 15 plus 2 is 17. Compile, save, come to level 1 and play. You see we got 17, guys. What actually the math expression node is doing? If I double click on it, inside it has created the graph of nodes. 3 into 5 is 15, 15 plus 2 is 17, that is it is outputting, guys. That is what it is doing. If there is no math expression node, then you have to design the blueprint for this expression. First you right click and search for multiply node, then you right click, then convert pin to the float, and then here you write 3 multiplied by 5, and then you use the add operator, and here you give 3 into 5 and here you give 2. So 3 into 5 is 15, 15 plus 2 is 17, that you give as an output. So it's a long process, but the math expression node makes your life easy, guys. Okay, you just write the expression, it creates the graph of nodes for you. Let's see one more example. Let's see one more example here. 2 into 3 plus 8 divided by 2. Okay, let's see. I delete this. I right click and say add math expression. 2 multiplied by 3 plus 8 divided by 2. First 2 into 3 should be evaluated, then 8 divided by 2. 2 into 3 is 6, 8 divided by 2 is 4. 6 plus 4 is 10, guys. So if I compile, save, come to level 1 and play, you see it has displayed 10. Behind the scene, it is creating the graph of nodes. You see that 2 into 3 is 6, 8 divided by 2 is 4, 6 plus 4 is 10 is written as an output, guys. That is what happening behind the scene. Understand this. Okay. Now let's see one more example. 3 into 5 plus 4 divided by 2 plus 3. Let me copy this entire expression from here. Okay, I delete this, right click, add math expression node, and here I paste the expression. 3 into 5 plus 4 divided by 2 plus 3. So as per the BODMAS rule, 3 into 5 should be evaluated. Then 4 divided by 2. 3 into 5 is 15. 4 divided by 2 is 2. 15 plus 2 is 17. 17 plus 3 is 20. So definitely you see it has put the brackets for us. 3 into 5, then 4 divided by 2, then 15 plus 2 is 17. 17 plus 3 is 20. So definitely we'll see 20 displayed, guys. If I compile, save, come to level 1 and play, you see 20 got displayed. And it is behind the scene creating the graph of nodes. You can clearly see here 3 into 5 is 15, 4 divided by 2 is 2, so 15 plus 2 is 17, 17 plus 3 is 20. It is returning back to us. So that is how the math expression node is used, guys. Okay, and as I told, math expression node can have input data pins. It can have data pins, and how the data pins come, I told you here. Identifiers are converted to data pins. Identifiers are converted to data pins. And what is a identifier? A single character or sequence of characters treated as identifiers. An identifier followed by parenthesis considered as a function, guys. So let's see an example here. I have x plus y multiplied by z. So x, y, z are converted to data pins. You can see here. Let's delete this. Right click and say, I say here add math expression node. I say here x plus y multiplied by z. If I hit enter, you can see that as per the BODMAS rule, it has rewritten the expression x plus in brackets y multiplied by z. And here I can give the value 2 plus 3 multiplied by 5. So what happens here? First 3 into 5 is evaluated 15. Then it is added to x, that is 2. So we'll get 17, guys. Compile, save, come to level 1 and play. You see we got 17. A single character or sequence of characters treated as identifier. It is converted as a pin. Okay, one more example you see. Area of circle calculator. What is the formula? Pi r square. So pi r, two identifiers we have here. So right click here and say add math expression. Here I say pi into r, pi r square. If I hit enter, you can see that pi is converted as a pin. 2 times we have used r, so it has created one pin for r. You can see that. So here I can give value 3.142 is the pi value, right? And r value I can give anything, like say 3. So pi r square, it is going to evaluate here. Now you can see that it is pi into r you can do, or you can rewrite this expression as per your requirement. Okay, it's looking like pi into r and then r. Instead of that, what I do, I remove the brackets from here. I put brackets over here myself explicitly. If I add brackets, it takes them as seriously. So pi into r, that is pi r square. Now I put the pin over here, compile, save, come to level 1 and play. We got 28.278. That is exactly correct, guys. Pi r square. So you can use brackets explicitly. You can define brackets, guys. Understanding? You can write like this. Here all are identifiers. One more way what you can do is you can right click and say here add math expression. I say here pi into, instead of saying r into r, I am going to say here pow. That is the power function that we have in Unreal Engine, or I can simply say power. Sequence of characters followed by pair of parentheses indicate a function. It is a function from mathematics, math library. So here I say r comma 2, which indicates x raised to the power of 2, r square. So it is treated as a function, guys. It is treated as a math function. You can see it has automatically written a code for us. And if I say a 3.142, and same I give 3 here, and I connect the pin over here, compile and save, come to level 1 and play. You see we got 28.278. That is correct answer, guys. So you can definitely use your math functions inside the add math expression node. And if you see in the math expression node, it has 2 input pins. One is pi and one is r. That is what we are giving here, pi value and r value. And inside it has done the power function. You can see it is using base raised to the power of exponent, right? So r is the input, r2, r square, pi r square, it returns the output. That is how math expression works, guys. Okay, just understand. You can see it has converted. Either you can use power or you can use POW, which is power, guys. So here we have square root of x square plus y square, a math expression which we can write to find the hypotenuse, right? So simply we can delete this, and you can say here right click, you can add a math expression. So you can simply say square root sqrt brackets. It is a function from math library, right? So sequence of characters followed by brackets is considered as a function. Then x square, so I say here power x comma 2, that is x square, plus power, I say here y comma 2, that is y square. I hit enter. You can see that it has rewritten the math expression for us, and here we can give the x value and y value. I give the x value 3 and y value I give 4. So here x square, y square, 3 square, 4 square. 3 square is 9, 4 square is 16. So 9 plus 16 is 25. Square root of 25 is 5, guys. So definitely if I compile, save, come to level 1 and play, you see we got 5, guys. And behind the scene it is creating graph of nodes. I double click, you see it has created the graph of nodes for us, guys, right? You can see x square y square, x square y square plus x square y square plus, we are giving square root of x square plus y square. It is going to return the output, guys. If there is no add math expression node, there is no math expression node, then you have to design this graph of nodes, right, by yourself. So it makes your life easy. That's about the math expression node, guys. I hope you guys have clearly understood. So remember that math expression node allows us to directly type a math expression, and based on the given math expression, it creates or designs a graph of nodes within it, and it rewrites the given math expression by following BODMAS rule, where B for brackets, O for orders, D for division, M for multiplication, A for addition, S for subtraction. First brackets are evaluated, then orders, then division and multiplication, then addition and subtraction. So at any time you want, you can use brackets to override this order. And identifiers are converted to data pins, right? An identifier followed by pair of parentheses considered as a function, guys. That's it, guys, for this video tutorial. If you like this video, hit the like button and share with your friends so that everyone will get benefited. In the upcoming video tutorials, we discuss more about Unreal blueprints. For more benefits and be up to date, do not forget to subscribe to our YouTube channel. Keep learning, keep designing, keep sharing. Thank you, guys. Thank you very much. See you in the next tutorial.